Welcome sa ating YouTube channel. Ang topic natin sa video na ito ay about sa first degree indeterminate beams using method of consistent deformation. So meron na tayong naunang part for trusses. So ngayon para naman tayo sa beams. So since beams ang ating concerned, meron naman na tayong mga other methods na ginagamit just like in 3-moment equation. Mas madaling kumuha ng reactions ng beams, and so as with the shear and moment diagram, kahit ilan pa yung kanyang degree of indeterminacy. So in this case, magfo-focus tayo sa pagkuha ng reactions sa mga rock beams. Okay. Determine the reactions and draw the shear moment diagram for the beam shown. So this is first degree indeterminate kasi meron tayong reaction sa A, moment sa A, and reaction dun sa roller sa point D. So now, kailangan natin magtanggal ng isang reaction so that magiging stable pa rin yung ating beam. Statically determinate at the same time stable. So it's either tanggalin mo yung moment sa A or yung reaction sa roller. So in this case, mas madaling tanggalin yung roller. So we are going to choose RD as the redundant. So kung tinanggal natin yung roller sa point D, ano yung mangyayari? Okay? So solving for the reactions, so this is now statically determinate. So 160 ito, then 780 ito. Since sinanggal mo siya, magkakaroon tayo ng deflection. Magkakaroon ng deflection dito sa point D. So we need here our basic knowledge sa pagkuha ng deflection at the free end of a cantilever beam. So if you do remember sa ating area moment method, na-derive na natin to. So the deflection at the free end is equal to what? PA squared times 3L minus A over 6EI, where A is the distance from the support. So gagamitin natin dito is negative kasi nasa ilalim siya ng original na position niya. So meron tayong calculator dito, kunin natin yung value. So we have 60 times 3 squared times 3 times 9 minus 3 over 6. Mamaya natin ilagay yung EI, no? Plus, okay, we have 100 times 6 squared times 3 times 9 minus 6 over 6. Okay, so meron tayong 14,760. At take note again, gagamitin natin negative kasi nga nasa ilalim siya. So ito yung negative 14,760 kilonewton meter cube over EI. Mamaya na natin ilalagay yung EI kasi baka mamaya hindi naman natin kailangan yung mismong value niya. Okay. So next, maglagay tayo ngayon ng unit load 1 dito sa point T, pataas. Okay? Bakit natin ginawang pataas? Kasi for sure, based on the loadings, pataas talaga yung reaction dun sa roller sa point D. Kung gusto mo naman pababa, later on makukuha mo naman yung deflection o yung magnitude ng reaction sa roller to be negative. Ibig sabihin nun, opposite siya nung sense ng direction na inassume mo. So since we are confident na pataas yung reaction sa point D, nilagay natin siya na pataas. Okay, so these are the reactions. Okay? So gagamitin naman natin dito si PL cube over 3I. So ang deflection naman niya pataas. So this is the delta double prime D. Okay, so we have 1 times 9 meter cube over 3EI times the magnitude of R na hindi pa natin alam, divided, this is equal to what? 243 RD kilonewton meter cube over EI. Okay? But since, take note, roller yung tinanggal natin sa point D, initially wala namang deflection doon. Okay? So, ibig sabihin, tulad ng ginawa natin sa trusses, delta prime D plus delta double prime D is equal to the displacement at point D, in which ang value nun 0 unless specified sa problem na ganito yung kanyang displacement, meron siyang value. Okay. Therefore, substituting delta prime d plus delta double prime d is equal to 0. So, substituting the values, we can notice that EI will be cancelled out. So, kaya hindi natin nilagay yung value kasi eventually it will be cancelled out. So, makukuha natin na value for RD is positive 1,640 over 27 or roughly 60.74. So, check natin. So, ito divide natin ng 243. Ayun. So, ayan po yun na. Kasi pag transpose mo naman siya sa kabila, magiging positive siya. Okay? So, paano kunin yung RA? So, we have what? 160. Okay? Remember kanina yung reaction sa point A. Okay? Nung wala yung roller support ay 160 kN. So, bawiin natin siya. So, 160 minus 1 times the magnitude of RD, ginawa natin ito sa trusses, is equal to this one. Okay? So, as with the moment. So, ginawa lang natin negative yung counterclockwise. So, kanina, yung moment doon sa point A ay 780 kN. So, times 9, yun yung magnitude ng moment doon naman sa unit load na 1 times the magnitude of RD is equal to negative 233.333 kN meter. So, lagyan natin yung mga nakuha natin na reactions. So, ito yung RD, 60.74. Ito yung RA, at ito yung moment sa A. So, sketch natin yung moment diagram, shear moment diagram. Okay, so, angat muna tayo ng 99.259, no? Walang load, so constant. Pagbawas ka ng 60, pababayan dito, no? So, that is 39.259. Mag-subtract ko ulit ng 100. Makuha mo negative 60.74. Then, yun, aakyat ka sa 60.74. Balik ka sa 0. Okay? Basic lang naman to, guys. So, next. Para sa moment diagram, meron tayong counterclockwise na 233.333. Point A, so bababa ka muna rito with that magnitude. And then, aangat ka ngayon ng ilan? Okay? 99.259 times 3. So, complete natin. We have negative 233.333 plus 99.259 times 3. Okay, that is 64.444. Kaya angat tayo ron, na? Ayan. And then, mag-add tayo ngayon ng 39.259 times 3. We have 182.221. Nilagay lang natin dito yung sakto, 182.222. Okay? And then minus 60.74 times 3. Yun, yung sinasabi ko na ito 0.001 yan eh. Kaya babalik naman tayo sa 0. Acceptable naman yan. Okay? So, here's our moment diagram. Okay? Let's proceed to our second example. So, ito po, yung problem na to, this came from CE Board exam, May 2016. An 8-meter high retaining wall is subjected to lateral earth pressure increasing from 34 kilopascals at the top to 136 kilopascals at the base. Fractional rigidity, EI, 4.5 times 10 raised to 14 Newton per square millimeters. Analyzed per meter length of wall. So, usually, ang situational problem, tatlo yung tanong. What is the moment in kilonewton meter at the base of the cantilever retaining wall? Number 2, to prevent excessive deflection at the free end, the wall is braced at the top. What force is required at the propped end of the wall to limit the deflection to 35 millimeters? And when the wall is propped at the top, what is the resulting moment at the base of the wall in kilonewton meter? So, for a retaining wall, vertical structure po yun, no? So, ito yung ating magiging figure. Ginawa na natin, no? So, yung magnitude ng pressure na 34 kilopascals and 136 kilopascals, multiply na natin ng 1 meter length. Kaya nakuha na natin yung intensity na 34 kN per meter sa taas at 136 kN per meter sa base. Okay? So this is just simple statics. Makukuha mo yung reaction, 680 kilonewtons. So as with the moment, 2176 kilonewton meter. Paano po nakuha yan, sir? Okay? So, lagyan natin dito saglit. We have what? 34 times 8 times 4 plus 1/2. Kailangan natin 0.5 times sa difference ng 136 and 34 times 8 times 1/3 ng 8. So, yan po yung 2176. Okay? Pwede natin siyang gamitan ng integration. Gamitan natin ng mode 3-2, pwede rin. So, when x equals 0 or h equals 0 and h equals 8. The magnitude is 136 at x equals 0 and 34 doon sa x equals 8. Let us get A. 136. Store natin kay alpha A. So, as with B, negative 12.75 store natin kay B. Then go back to mode 1. Let us integrate. We have integral of A plus bx from 0 to 8. Ito po yung 680. Lagyan natin ng x. Ito na yung moment. 2176. Okay po ba, guys? So mamaya kasi magagamit pa natin tong A plus bx na to sa pagkuha ng deflection. Okay. So dahil nga retaining wall to, no, free yung end niya. So most likely magde-deflect talaga yan. So ngayon, sabi niya sa number 2, to prevent excessive deflection at the free end, the wall is braced at the top. So may tutulak sa kanya na puwersa. Okay? So yun yung deflection sa point B. So ngayon, magtutulak tayo ngayon ng puwersang RB. But not the full extent na matutulak niya ng hanggang sa original position. Sabi niya rito, ilan yung required to limit the deflection to 35 mm. So unlike kanina na ang deflection ay 0, ngayon naman may matitirang 35 mm, which means kapag tinulak ng RB, hindi niya fully may babalik dun sa original position ng point B. So dito lang. So we will call this as delta double prime B. And itong delta B, obviously, yan yung 35 mm. Okay. So, take note that delta prime B plus delta double prime B is equal to delta B. Okay, in terms of magnitude. So, since yung delta prime B ay pababa or pakanan, rather, ng retaining wall, as per the drawing is concerned, negative yung magnitude niya. On the other hand, yung delta double prime B, positive kasi pabalik siya ng point B or pakaliwa yon. On the other hand, yung delta B, negative din kasi nasa ilalim siya or nasa kanan siya ng original point B. Okay, kuha tayo ng strip dito, y dx, in which yung y, yun yung nakuha natin na a plus bx kanina. So remember, magagamit pa rin natin dito yung PA square times 3L minus A over 6EI. But this time around, okay, ito yung X na. Integrate natin kasi this is a series of concentrated loads na magkakadikit. Therefore, sum up natin yung kanilang effect by using superposition. Take note guys, negative yung value dito. So we have P, ito yung 136 minus 12.75x dx. Okay, then yung force. Yung A is yung x squared. 3L minus A is this one over 6EI. Makukuha natin ay ano. Kailang, integrate natin guys na. So mas maganda, dahil naka-store naman tayo, ilagay na natin yung eksakto. Okay, x squared. Yung 3 times 8, ilagay na lang natin na 24 minus x over 6. Okay? From 0 to 8. Okay. We have 31,334.4. store natin kay C. Mamaya kailangan natin yan. Okay. Yun no? Parehas ba? Yes po, parehas. So next, doon naman tayo sa delta double prime B. So katulad nung kanina, we have RB times 8 meters cube over 3 EI. Ilan ba to? We have 8 cube divided by 3. That is 512 over 3. So times RB. Yan po yung value niya, no? And take note that delta B is not 0. Ito naman ay negative 35 mm as explained a while ago. Kasi nga nasa kanan siya ng original position. So by substitution, or rather, kunin muna natin yung value ng EI. So, we have 4.5 times 10 raised to 14 Newton square millimeters. So, convert lang natin siya into kilonewton square meters para constant yung ating units. So, substitute natin. So, ito yung mga values, no? If you notice, magka-cancel out yung mga units aside from meter. Kaya ginawa nating 0.035 meters yung 35 millimeters para consistent tayo sa units. Therefore, we get here the value na 91.31. Try natin na. Okay, store natin to kay D. So, we have what? Yung value nito. Okay, ito yung C, no? Over 4.5 times 10 raised to 5. Okay, negative natin, no? Negate natin. So, negative 0.035 minus the answer. Ito yun, no? Okay. So, na-negative pa yung answer kanina. Okay, wait lang po. Ayusin natin. Negative answer. Ito yung part na to. So, pagdating sa kabila, magiging positive siya. So, negate na lang ulit natin. Minus 0.035. Okay, divide natin ng 512 over 3 times 4.5 times 10 raised to 5. Okay, yan po. Nakuha na natin yung 91.31 kilonewtons. Okay? So, store natin siya sa letter E. Okay. So, ngayon, solving for MA when propped. Okay, we have what? Yung kaninang 2,176 kN meter minus 91.31 times 8 meters. So, medyo basic naman yan. Kasi yung moment nito dito sa point A ay ito mismo times 8 meters. So, tingnan natin. So, 2176 minus 8 times yung magnitude ng RD na 91.31. Gamitin natin sakto. 1445.48. So, ito po yan na. Sorry. This is MA. MA po ito guys na. Ito, baguhin natin. Ayan po yan, no? And then, kung gagamitin din natin, or kung ilalagay din natin yung reaction sa point A, we have 588.69 kilonewtons. Okay? So, there are so many applications of this one. Abangan nyo po yung susunod natin na topic, which is multiple indeterminacy. So, I would like to samantalayin yung pagkakataon para mag-promote ng konti. Okay, so I'm promoting po yung aming libro na Engineering Mathematics and Applied Sciences. Ito po ay mas kilala sa engineering or civil engineering twilight. Okay? So this is a review book actually po, no? Multiple choice with solutions. So kompleto po yan from algebra, trigo, geometry with vectors, calculus, differential equations, probability and statistics, statics of rigid bodies, dynamics of rigid bodies, physics, strength of materials. Meron din po itong engineering economy. Hindi lang po nalagay sa presentation. It has a conventional solution with an alternate solution. Yun po yung mayroong shift solve strategies. And not just that shift solve, para mapabilis yung ating solution, ginamitan natin siya ng technique sa calculator. So, for more information, please visit our Facebook page. Okay, facebook.com/ctwilight. So, ano pang hinihintay nyo guys? Grab a copy now, no? So, don't forget to like, comment, share, and subscribe to my YouTube channel for more updates. Thank you.